All right, here we are, back at it again. So I just want to go over a couple examples for the maximum and minimum values that you learned about in the book. So here's just a couple of examples of equations, and we are just determining whether the function is going to have a maximum or minimum value. And again, that is based completely off of what is the letter a, or the number a, which is the number in front of the x squared term. So remember, standard form for a quadratic: ax squared plus bx plus c. So when we refer to a, we are talking about the number that is in front of x squared. If a is a positive number, so in your book you would have seen if a is greater than 0. A is greater than 0, that means positive. Then it's going to have a minimum. And then the opposite of that. So if a is less than 0, so if a is a negative number, then you're going to have a maximum. And so we'll go ahead and answer whether they have a minimum or maximum first. So here for number 1, our a term is a negative, or it's -4. And that means that the a is negative, which is the second one here, which means this is going to have a maximum. So that means that this graph will look like this. It'll look like, call it a mountain, look like a mountain. And it's going to have a maximum value up here at what we call the vertex. All right, so 1 is max. Okay, for number 2, the a is a positive 1, and since it's a positive 1, it's going to look like a u, which means it's going to have a minimum value. For number 3, the a is also positive 1, so same thing, going to look like a u. It's going to have a minimum value. And then 4, why did I do this? Since there's a negative out front in parentheses, you should first distribute that. Okay, so when you distribute a negative to a negative, it's going to make this a big positive in the front. And it's going to make this a positive. So all we really care about is the term in front of x squared, which again is going to be made a positive. And because it's positive, that's again the first one here. So that's going to be a minimum value. Also looks like a u. Now, what are the values for each? Well, we would have to do a little bit of work and find the vertex in order to answer that question. To be honest, one's going to give us a fraction because we're going to do negative b over 2a. It's going to give us a decimal. I'd really rather not. Number 2 is pretty quick. So let's just do that one quick, and then we'll move on to the new stuff. So b, in this case, there isn't an x term in the middle, so the b is 0. So if we're plugging into negative b over 2a, our b is 0, and our a is 1. So this is 0 over 2. So this is 0. So our x is 0. So for our vertex, our x value is 0, and we would plug that back into the function to find a y. So if I plug a 0 back in here for x, I get 0 squared minus 4, which is -4. So for number 2, this function has a minimum value, and the minimum value is -4. All right. And let's, real quick, let me just show you something. Let's take out our calculator here. So let's take this calculator out. Okay, if you go to y, turn it on, go to y equals, type in that function. So type in x squared minus, type in x squared minus 4. So here's x squared minus 4, and you graph. All right, you get a look at this thing. You should see that there's a minimum value, and honestly, you could probably count, the dashes on the y-axis here. So 1, 2, 3, 4, and you can see that that's down there at -4. Or you can do the work that I just did. This isn't always accurate because as soon as, let's say, I don't know, we get some random stuff in here. Oh, this is going to be, let's not do that. Let's do 1. You can see sometimes it's not so easy to count. I mean, this one's really not that bad either, but sometimes it's not easy to count and know exactly where that's at. So doing the algebra is sometimes important. All right, let's move on to the new stuff quick. This is solving quadratic equations by factoring. So we're going to be solving them now. And to solve them, we are going to find something called a root. And a root is just simply another way to say the solution of a quadratic equation. All right. And one method of finding the roots is to find the zeros of the function. So for right now, the word root. So you should be writing this down. The word root, the word zero, and the word solution all mean the same thing for quadratic equations. All right, so roots, zeros, solutions all mean the same thing. And on the next slide here, I'll show you how you find them. And the first thing we're going to do is we're going to learn how to find them by looking at a graph. All right, but those three things all mean the same thing: roots, zeros, solution. All right, how do you find them? Did I just talk about this? The solution of quadratic equations are called roots, and you can find them by finding the zeros because roots and zeros are the same thing. I already knew that. So how do you find the roots? Well, the first thing is you're going to figure out if the graph crosses the x-axis. Remember, the x-axis is the one that goes left and right. If the graph does not cross the x-axis, then there's not any roots or there's not any solutions. If it does cross the x-axis, then our roots are wherever it crosses the x-axis at, which are called x-intercepts. All right, so all we have to do is figure out where the graph's crossing the x-axis. Those are considered the roots of the function. Those are also considered the solutions of the function, and that's all we really need to know. So let's go on to here. So it says, what are the roots? Well, first of all, let's see. Does this thing cross the x-axis? And the answer is yes, and it crosses the x-axis at two different points. So this one right here and this one right here. So I could say that there are two roots to this function. And what are they? They are the numbers where it crosses the x-axis. So this one is a 1. This one's a -5. So in this case, whenever I graph this, this would have two solutions or two roots, and it would be 1 and -5. Do not put parentheses around these numbers. All right, so the proper way to write your solutions would say x equals and do brackets, and I'm going to be terrible at these. So there's a little squiggly brackets. All right, and -5 and 1 are the roots. And it doesn't matter what order I write them in. So if I put the 1 first and the -5 second, it still means the same thing. So there's two solutions. If you want to think about this, is like when we did absolute value equations in Algebra 1, there were two answers to most of those questions. Same thing. There's two answers to this question. So the number -5 and 1 are both solutions. That was my try to parenthesis, but don't put parentheses like this, because remember, when you do that, that means an ordered pair, and that means that the one number is an x and the other number is a y. That's not what we're doing. Both of our numbers are x's, and they're both solutions. So try to use brackets if you can. Honestly, not using anything is fine too. So put -5, 1 like this. That'll be a fine way to write your solutions as well. All right, so again, roots are x-intercepts. Where does it cross the x-axis? I wish I could zoom in to show you a little better here, but this thing is bottoming out and turning back up, and it's going to intersect here just at one point. It's going to touch the x-axis for a very, very, very short period of time. And where does it do that at? It's at the x value of 0. So this has one solution, or one root, and it's a 0. All right, one more. What are the roots of this one? Well, you can see the x-axis is down here. This graph is above the x-axis. It does not touch the x-axis. So this has no roots, or this would have no solutions. No solutions. All right, so keep in mind that they don't have to cross the x-axis. Okay, and then you might get a couple word problems. I'm going to go over one here just to introduce these. Most of these word problems, we're going to be using the calculator to answer them. So it says a ball is launched into the air, and it models, this function models the height of the ball. So t is our seconds, and if I plug the amount of seconds in, whatever number it spits back out to me would be the height of the ball. All right, so when you get word problems like this, take your function, go to your calculator, type it into your calculator. All right, let's go to y equals, type -16t squared minus 80t. Okay, so here's my example. Now you can go to the graph. What you're going to notice is you don't see much. You just see a vertical line here and then nothing over here. That's because I made a typo. I'm going to make your guided notes have a plus there. But it should be a plus. So let's go change that to a plus. Sorry. Now it still won't look great, but it looks better to me. The reason you don't see much here is because our window is not showing us high enough off the ground. So if I go to window and I move this, let's see, where can I move this? Let's move it. I don't know, just to give you an idea of what this looks like. Okay, yeah, so you can see it's like launched up in the air and then it comes back down. And if you want to change your window and change your Y max even higher, we can like 250. We might be able to see where this thing stops. Yeah, so there you can get a better look. So that's what it looks like. Number 1 says, when does the ball reach its maximum height? So they'd be asking us, where's this top point? And to answer that question, we would just be finding vertex. Excuse me. So maximum height, find the vertex. That's when this thing has its maximum value. What is the max height? Well, that's also the vertex. Okay, but this would be finding the y for the vertex. This would be find the vertex. You just need the x. So let's just put find x, and you can do negative b over 2a to find that. So that's going to find the center, which is where the maximum height is going to happen at. What's the maximum height actually? It's the y coordinate of the vertex. And then 3, when will the ball land? So for now, it's just an introduction to this. You can estimate, so you can just count over where at on the x-axis it lands. Landing means the height is 0. It hits the ground. So you're looking for the x-intercept. You're looking for the root, what we just talked about. So it looks like it's 1, 2, 3, 4, 5. It looks like 5 to me. There is a way to calculate this, but I'll show you that later. We could zoom into that area, but that'll be more confusing. So for now, we're just going to say it's 5, 1, 2, 3, 4, 5, or approximately 5. And we'll be able to find that number exactly later. But that's going to wrap up what we do today. Thanks for watching. Might post this on YouTube so you guys can like and subscribe to my channel.